Hello and welcome to this new episode in this series. In this video, we are going to look at the different classification of approaches that are used in machine learning. So, the types of machine learning. The first type of machine learning we have is the supervised learning. What I need you to remember, or what I need you to take from this lesson, is that machine learning algorithms, or the approaches to machine learning, can be classified based on the amount of supervision that the algorithm gets. And the first type of machine learning is called supervised learning. And the supervised in the phrase supervised learning is due to the fact that in supervised learning, the data you use to train your model, which we also call the training data, has both the input and the expected output. Okay, so you give it both input with expected output. So the expected output here is the supervision that the algorithm is getting from you. The fact that you're not just throwing data at it, but you said, hey, for this particular data, I want you to predict this. For this data, I want you to predict this. That mapping of input to output that is captured in the training data is what is known as the supervision. And that is what makes it a supervised learning algorithm. And some of the examples of these supervised learning algorithms are mainly classification, and regression. So in classification, we train a model to be able to predict the class of an input data. So for example, a classification problem is trying to train a model that can tell cats and dogs apart. So you feed in an image of a dog and then you expect the model to tell you that this is a dog. You feed in an image of a cat and you expect the model to tell you that this is a cat. The way you supervise this is in the training data, you need to give it thousands, tens of thousands of images of cats and dogs that have been manually labeled by a human being. And that is how you supervise it. So the computer is supposed to find a mapping between the input and the labeled output that you have given it. And when it comes to linear regression, it is similar to classification, except that in regression, you predict a real valued output. So in classification, you are usually predicting scalar numbers or classes. So something cannot be in class 1.5. You are either in class 1, class 2, class 3, class 4, class 5. But with regression, you are predicting a real valued output, so it can be any number. And these are the two common examples of supervised learning. And the truth is that most of the economic value that we are seeing from modern machine learning and deep learning for that matter is residing around the supervised learning approach to machine learning. So that is one example, and we are going to go deeper into every one of these. So the next type of machine learning is unsupervised learning. And as you can imagine, if supervised learning has to do with training data that has labeled expected output, then unsupervised learning is machine learning where the training data has no labeled output. So how this works is that you have a large data set, you have tons of data. You throw it at the computer and or the machine learning algorithm or the model, and the question is, hey model, tell me what you see from this data. Okay, the reason why it is good to use computers for some of these things is that they are faster than human beings. Imagine you having to process a million records to find patterns in there. It won't be long before you get tired and even lose sight and lose track of what you have seen so far. So in unsupervised learning, you throw a bunch of data to the algorithm and you expect that the algorithm is going to tell you or discover patterns that it finds in the data. And over here, the common things that we use unsupervised learning for is clustering, and then we also have dimensionality reduction. Dimensionality reduction. So you throw your data, and then in clustering, what happens is that the algorithm is going to come up with groupings in the data set that you threw at it. Let me give you an example. Let's say you run an e-commerce website, and then you've been able to acquire a lot of information about your customers, and you don't know what is common amongst these customers. What you can do with an unsupervised learning algorithm is you throw this gigantic data at it, and then it's going to group them for you. So out of the grouping, you might discover that people between the ages of 18 and 25 like buying electronics, and people between the ages of 25 to let's say 35, they like buying cars, and then people between the age of 35 to 70, they like buying household equipment, chairs, tables, and stuff like that. These are things that unsupervised learning algorithms are able to bring out, and that is what we call clustering. And an example of that algorithm is called k-means clustering. One other thing we can use unsupervised learning algorithms for is dimensionality reduction. You know, once we begin to get practical with all these things we are learning, you see that the training data that we give to the models to learn are very high in terms of dimension. Okay, so the amount of features, what you store about your training data, are so much that sometimes to visualize them it becomes difficult. I mean, we can easily visualize things in 2D, and then we can visualize in 3D. Anything above that becomes difficult for our minds to envision and for our eyes to even perceive. Okay, so sometimes it is important that you take a very high dimensional data and you reduce it into a low dimensional data without losing any important information or any important pattern in the data. And that is what dimensionality reduction algorithms in unsupervised learning does for us. And for that, some of the examples are PCA, which is principal component analysis, and then we also have t-SNE. These are all unsupervised learning approaches to machine learning. Our focus for this course is going to be mainly around the supervised learning approach to machine learning using deep learning techniques. Now, the third form of machine learning that we can think of is reinforcement learning, which is quite similar to how we learn in everyday life. What reinforcement learning does is it gives, so you build what is called an agent, which is usually your program, an agent that interacts with an environment, interacts within an environment, and the vision is to try to optimize its expected rewards or optimize an objective by receiving rewards, and rewards can be negative or positive from the environment. This is usually used in robotics and even online trading, online advertisement, and mostly things that have to do with taking sequential decisions, making sequential decisions. Okay, so reinforcement learning is also another thing altogether, unsupervised learning, and all these three here deserve courses of their own. And in this course, we are going to focus entirely on supervised learning. And what I need you to note is that especially supervised learning and unsupervised learning are not very exclusive to each other. They are not mutually exclusive. It happens that sometimes in a data transformation pipeline or in a machine learning project, you have to merge techniques from unsupervised learning with supervised learning to get your goal. For example, if you got a data set and then the features in your training data set is about 100,000, That is way too much, and it will result in something called overfitting. You understand that later. It will result in something called overfitting. Now, one way of fighting that is to reduce the dimensionality of the data. So you see that even before you begin solving the problem with supervised learning, you run some unsupervised learning algorithms to reduce the dimensionality, and then you can peacefully train your model with neural networks to achieve that purpose. So these are the types of machine learning, and our focus is going to be on supervised learning. So thank you very much for watching, and I'll see you in the next video.